Okay, good afternoon, everybody. Thank you for showing up at the witching hour for presentations. For all good presentations go to die, but here we are. Thank you again for joining. I'm going to talk a little bit about AI-enhanced service assurance. My name is Tom Carroll, and I'm from Enghouse Networks, and I've been in the service assurance and even security information management for most of my career. I came out of Harris Corporation in Melbourne, Florida, where they are a defense contractor, but also they do critical systems, border security, and microwave systems all over the world. So I've got to go to really nice places like Mozambique and other places where you wonder why you're going. But I am from Florida, and I do have a hurricane plan, as every good Floridian should have. And when you get hit by 4 hurricanes in 43 days, the best planning doesn't really matter anymore. Now it's about your disaster recovery plan. And then roll that forward 20 years to last year when Hurricane Milton cut across the state and then went up and re-landscaped most of North Carolina. Those are events that you can do your best to plan for, but you can't prevent the critical communication loss that you have there. Most of the critical communications during that last hurricane were actually very effective, especially in Florida, because we get the notice of hurricane warnings, then you get storm surge warnings, then you get tornado warnings, then it's very specific by county, so it even gets to the point of information overload. But we're going to walk through kind of that critical communications infrastructure and AI and how they intersect and look forward to what's in the future. So we'll start with just that ecosystem, which is very complex, very integrated, very specific to critical communications, but also the surrounding supporting infrastructure. Then to just give a brief overview of today's end-to-end service assurance, what that really means, what it looks at, especially as you apply it to critical communications. And then we'll transition into the AI conversation. We don't have enough time to really deep dive into a lot of the technology, but we'll go more towards its application, especially towards service assurance and then the preventative measures on that. And then we'll do a case study, one that we've been involved with over the years, going back to 2016, 2017, on doing proof of concepts with service providers specifically for AI-enhanced service assurance. So if you look at this infrastructure, it is, it's really, these are bidirectional arrows, but it's not only the P25 network or the Tetra network, if you're especially in Europe. It's also the surrounding systems, the power systems, the remote sites that are holding critical communication infrastructure. There's also HVAC, battery banks, rectifiers, generators that need to be monitored, fuel levels. You have the emergency broadcast systems itself, as well as weather systems that are providing information into this ecosystem. So as you can see, very diverse, lots of different organizations involved. We're not going to go to the inter-agency communication. That was actually a session right before this, which is its own, but we'll focus more on just the specific infrastructure monitoring with AI. So from an AI, not a service assurance perspective, this is something that I've been involved with for most of my career. Really, it's around a best practice called FCAPS. It's a fault management, performance management, configuration management. You have security management as well. But it's really an umbrella management system, and we use the term end-to-end because the end-to-end nature, anything that can and will impact the quality or the availability of a service needs to be under this umbrella. That means multi-protocol, multi-vendor, multi-domain, all the way from the physical layer of what's happening with fiber in the ground to the transmission layer. You have fiber in, microwave, satellite communications, but also all the way to the application layer. You have databases, you have CPUs, you have all kinds of different things you can monitor, interfaces that can bring down a service. So they're all in play for fault management, as well as performance management. It's a little different. It's more proactive. You're reaching out to critical infrastructure, asking for a number. That number could be what's your utilization, and again, like CPU utilization, disk space utilization. It could be the temperature in a room. It could be the fuel level at a remote site. All of those are things that you can track, and you can identify trends. And so it's more not only proactive, but it allows you to see trends in what you're monitoring, not waiting for a fault, but being able to get ahead of it. Then we have event correlation, which has been around for a long time. Event correlation, which looks at the events only, the sequence of events, how many are occurring within a short period of time by a geography or by a specific piece of equipment. You know, what's the noisiest piece of equipment you have in the network. But it could also be root cause analysis based on the topology of your network. In other, you understand what's connected to what, usually by looking at the element management systems or the system of record that shows you what your network topology looks like, so that when there's a break in the topology, you can determine the root cause based on where all the other alarms are coming from and what you can still talk to. Trouble management is well defined, very specific system for workflow. It's kind of the system of record that kicks off SLAs. So if you're running a managed service, the clock starts when you open a trouble ticket, and the troubleshooting starts. Somebody gets assigned, a priority is assigned, or a group is assigned, and then it's tracked, and then that person closes the trouble ticket, and then somebody validates that it was actually resolved. The company's business workflow, their intellectual capital is usually wound up in here's how we do business when something goes wrong. And then all of that goes into reporting and dashboarding. So traditional reports, people used to email them around. Here's the daily report, the weekly report, the monthly report. Nowadays, that's evolved to dashboarding, where it's really a link where everybody goes onto the same dashboard. And in real time, they can see up-to-the-minute stats, and they can drill down and interact with those statistics instead of just looking at what they get. That is very much the next gen of where the reporting is going to. But the value comes from being end-to-end. Right? Not just reporting on a single system, you can do that, but you can report on that in context against everything else in your network. So now we're going to transition a little bit to the AI business context of this. And I don't know how everybody else feels about this, but it's really been unbelievable, the velocity, the ubiquity, the magnitude of AI recently. If you just look at your browser and see an AI assist agent there helping you with your search, that's just the tip of the iceberg of what's happening. Most businesses today have already integrated AI into some function that they do to help them be more efficient, faster, better at what they do. The 15 trillion to the economy, that's a Forbes and PricewaterhouseCoopers number. They're creating their own business just around AI, you know, as far as AI consulting, AI implementation, AI best practices. And I was just at Mobile World Congress a couple weeks ago in Barcelona, and hundreds of new AI companies, either the AI, they're embedding it in a piece of hardware, or AI specifically that has a unique use case. So I would say it's inevitable, maybe not unavoidable, but it's inevitable that AI is going to impact most of what you do, especially the electronic means in your life. Are you getting the utopian or dystopian feel? That's me. I'm engineering. I'm somewhere in the middle. I could see both sides of that, but definitely want to keep an eye on it. So now we're going to intersect those two disciplines. We have the AI on one hand, we have service assurance on the other. The fault management, where you're reacting end-to-end service assurance. Now what you're doing is you're not reacting, you're predicting faults based on the history of the fault, based on the end-to-end nature of the data that you're collecting and that you've cleansed, but also prioritizing that, understanding the context of this critical alarm versus that critical alarm. This one is much more expensive in terms of time to repair, in terms of the people that are impacted. That one can wait. That simple context on the fly is very, very valuable. As far as if we jump forward to the end of the presentation and looking at what's the easiest use case to solve, this we found just from our experience is probably the easiest thing you can do in your network if you're doing service assurance, just based on your historical data through a cleansing exercise, fine tuning, and being able to predict what's happening with a high level of accuracy. That's one. Other ones may be a little bit more complex, involving images or audio, things like that. But that one is definitely doable. Now, service assurance, customer experience management, service optimization. This is, and it closely ties with what's below it, the closed loop, is really where we see a lot of movement nowadays, and we do have customers who are doing this today. You'll hear the term AI agent. That's a new term around an autonomous agent who's troubleshooting, who's identifying issues, making recommendation, and fixing things on your network. And it's not a person, right? It's an actual function within your service assurance umbrella. That goes closely with the what I would call the assistant, virtual assistant, and chatbot with the workflow trouble orchestration now. We actually use this with our managed services because we do provide cloud-based services. And we have AI as far as telling agents what to say, detecting customer sentiment based on their voice pressure, the tone, their volume, what they're saying, providing recommendations for actions of what they should do. So this is actually a very valuable assist to help people be more effective in their roles and their jobs. And then analytics is AI-based analytics is one I think that is just now upcoming, because if you're going to implement this, you want to measure it. You want to understand how effective it is, how it got it right, how it got it wrong, how it could have provided other context or other information. So the whole AI analytic component, not only about what AI is doing, but maybe also how it's helping your team do what they do better. Are we more productive? Was it worth the cost? So that's definitely an interesting angle on AI analytics. So transitioning a little bit to more the purely preventative, this does overlap with regular service assurance, but these are things that customers are doing today. First is computer image analysis, and this has a couple different flavors. One, South Florida Water Management is a customer of ours, and they're using satellite data to watch the vegetation as it impedes on critical infrastructure, because they control the water as it goes through the state of Florida, and they need to make sure that it's not being impeded by branches or overgrowth, and they actually fly helicopters out and clear the right of way. So they use satellite imagery for that. They're now intersecting that with AI to be able to determine when and predict when that is going to impact the critical infrastructure. The same is true for towers, bridges, things that require federally mandated inspections on the integrity of those things. Drones are widely being used now to do those inspections, but to take the actual imaging and put it in an AI analysis to determine the previous image versus this image versus the next image, to see structural decay occurring, to prevent a failure that you can prevent, right? And especially high wind scenarios like we have in the state of Florida, that's really critical around cell towers and around microwave and other critical infrastructure. That also helps in the digital twin, just a fancy word that means you have a computer model of your infrastructure, your network, your communications at many different layers. This has many benefits in the analysis of your network. One, you want to do a single point of failure analysis on your network based on schematics. So you designed your network this way, but it may not be that way any longer, especially if you use AI to analyze the traffic on your network and automatically generate an as-built or as the traffic flows through your network. That might be a different view than what you're looking at today. And also make recommendations on where you may want to consider redundancy or an alternate means. A lot of, like Florida Power and Light in Florida, they outsource, they lease lines from AT&T and Verizon where they don't have communications there as just backup. They don't use them until there's a disaster and they lost infrastructure, and then they bring those online. It's really one that allows you to do simulations as well. If this piece of infrastructure fails, what services are impacted, what customers are impacted, how serious is this, so that you can learn, one, even in a disaster recovery, hey, we've seen this simulation, we know what's possible, and here's the answer to that. North Carolina, I think they even ended up flying in Starlink base stations so that they could provide communications to these people you couldn't even reach with cars or anything. The other one is simply predictive maintenance, which is very similar to that, but that's more based on your maintenance records, your expected life for even things like fiber, which you could get 20, 30 years out of fiber, but understanding when it's due for its failure time to be able to preventively replace that. It really also can do a risk assessment for you based on the information that you provided. These things are a little bit more complex in terms of identifying what your risk assessment number would be, what's calculated in that risk assessment. Definitely a little bit more complex, but it's doable and things that some people are trying to do today. I mean, if you look at IBM, Microsoft, Google, everybody has an AI times 10 of what they're doing. And if you subscribe, like we do, we subscribe to an AI engine, the amount of analysis that's available to you versus just going to ChatGPT is really unbelievable at what you can do. And what we can do is what I want to show you next. So we are a member of the TM Forum, which is the standards body for telecommunications. We've been doing Catalyst projects there for many years. The specific to AI is one we started back in 2017, which was in partnership with two service providers that were international, DO in Dubai, Sri Lanka Telecom, and we had a scientist from the Florida Institute of Technology together with us providing our technology to do AI machine learning service assurance, where if you look at the diagram, we're doing fault information performance, we're doing weather information, trouble ticket information, so it was a very diverse set, and it was about 3 months of data each, so we're talking hundreds of millions of fault event records, hundreds of thousands of trouble ticket records, an incredible data cleansing and normalization exercise as you go kind of through the snake towards the other end, towards prediction and towards action. And the action was to re-provision a component of the networks to prevent the service outage, right? So this was one back in 2017. This was before the generative AI that we have today. In 2020, we did another one that was based on voice recognition, asking the system, please show me the predicted failure on this segment of the network in the next 90 days, or show me these metrics associated with the quality of our service based on a specific vendor. But it was really more around just the AI voice recognition pattern that would query the system and then provide the results to you visually. And now we're doing one this year that is really the AI agent, is what it's called, AI Agent Assist, to where we're taking the same types of information, the fault performance and best practices is what they're calling it. It's really the recommended workflows for these types of situations, and fully automating it, going towards autonomous networks to where, zero touch provisioning. You have to be very confident in your AI outcomes. And I always just the way I look at it is you have to limit the inputs at first and limit the outputs so that it's not infinity to infinity, but it's very specific alarm normalization, trouble ticket normalization, environmental information, and then outputs are very discrete actions that you can control. You can make them semi-automatic if you wanted to. Here's a recommended action. Please respond, and then allow it to do that. But through this whole process, we've learned a lot about it, and we have our chief scientist, who's the one who's done all of these and is our lead. He's really bringing this to the forefront, making it more commercially viable for everybody, because this is somewhat non-trivial to combine all this information, normalize it, tune it, and then have it be fully automated, and then have it be predictable every time. So I had a couple different conclusions here on my side, and then I figured, okay, what does ChatGPT think a good set of conclusions would be for AI-assisted service assurance? I mean, one, clearly AI is a very powerful tool in understanding what's possible and starting off with very achievable objective is a good best practice. It's really here, it's a great tool to enhance the workforce, but not to replace the workforce, especially in this type of arena, critical communications where people's lives are at stake. You need those people with the skills that have a tool that can help them do their job faster, better, more effectively. It's definitely not, like I said, it doesn't seem like a luxury anymore. It doesn't seem like you could, it's inevitable. Let's just say the word, it's inevitable. And that it's being used so widely nowadays. It's really just how do you implement it into your operations now. Think of it as a box that learns, and you have to teach it. So you need an instructor. You have to have an environment that can handle that kind of processing and walk forward down that path of being able to achieve results with it, and then trust it, and then go forward. That was my data scientist, as he said, please stress the quality aspect of the data, because it's really sometimes the determining factor between success and failure is just the quality of your data. And it's like painting a house. You spend more time prepping than you do painting. And it's similar with AI. You really have to make the investment in your data quality. And that's where, in service assurance, it's always been helpful to this, because you're always collecting, normalizing, filtering the data anyway, if you're doing end-to-end. And so you already have a great repository of that data. And then going to the next step is easier, because you've already gone through the hard work of collecting, normalizing, and filtering that data out. That's just a good foundation for leap forwarding to the next step. I'm not going to read the AI ones, but they're pretty common sense, I guess. But I'd like to thank you and ask for any questions, please. To the mic. You're gonna.
So what type of AI models are you guys using? Is it one of those commercial ones that are available in the marketplace, or you guys have developed your own? Kind of which ones are you using? And then more importantly, I guess, how are you ensuring security of the data, particularly in the AI environment that we live in, where breaches and all that occur pretty regularly? So.
Right. So as far as the models go, one, we do have a subscription to Microsoft, as they're a business partner of ours already. Two, we are creating our own custom model, because what we're doing, instead of having it be everything, we're training it specifically on a series of actions that are applicable to critical communications, applicable to service assurance, ones that are agile enough, and I just watching them work with it and providing new actions is pretty amazing. So we're not here to promote Microsoft. I think you could use anybody's, really. If you are going to market with a solution, I think you should look at, once you understand the commercial models, creating your own is probably the most effective way forward. "3:30 on the afternoon."
If nobody's asking, let me ask this, why did you guys pick Microsoft over anybody else, kind of?
I think that it's more out of convenience. They are a corporate partner of ours. I mean, we're also partnered with Amazon for cloud services and with IBM. I think the economics and let's just say that the economics of it was the most beneficial for us. I don't think we felt we were leaving anything on the table with another vendor by not going with them. So maybe more convenience and economics. Any one of them could do it, honestly. Sure.
Could you talk a little bit more about how you use the AI-generated digital twins, how effectively they were as opposed to buying something from like Siemens who would make the hardware?
So AI-generated digital twins, one, there's a couple aspects, and it's not necessarily new technology. As far as if, for example, you want to buy a Cisco lab environment that's all virtual, very similar in terms of the simulation, but it's doing traffic analysis to determine what's connected to what's being routed to what are the nodes on the, MAC addresses, all those pieces of information. The other one is a lot of people have schematics that network designs, still physical, or they're in spreadsheets and it has just the attributes of the devices instead of the actual connectivity visualization. Or you use like a CAD system or Esri, because you have to understand the geography, the location aspect of it as well. That aspect is definitely more complicated and complex, because then you have to train the image detection, where are the edges, what is the classification of the device, what is the connectivity between devices, what are the borders, what is a location. So it definitely takes longer to do that. But the digital twin aspect of it is one that we provide solutions that do that for fiber networks or copper networks, that you can import existing electronic means to do it, but once you go to a hard copy or something else, it's a lot more complex, right? And so it definitely is one that's interesting. The digital twin, we're a big believer in that. It's part of the digital transformation, that you have an electronic copy of what your network actually looks like for simulation, if nothing else, or to understand topology changes and/or configuration changes.
Was it what you thought it would be, or was it like, oh, okay, we're doing that?
We do have it on our website, the actual case study. The surprise was, there was a good surprise in that it was actually a lot higher accuracy than we thought it was going to be. So above 80 and 90% prediction, just based on 3 months worth of data, that the cyclical, the weather components, and they're in the Middle East. One was in the Middle East. Sri Lanka was more. So the weather components played differently, but the accuracy was surprising at how accurate it was. The initial data quality was incredibly poor, right? There was so much data that was incomplete, irrelevant, especially trouble ticketing data where nobody put in what was the solution. So there was a lack of process that contributed to the poor data. But that just meant those records couldn't be included at all, right? And then training the system, fine-tuning it, filtering the data, fine-tuning it, then it started to happen. The predictions started to get better over time. Thank you.